we are live. Let's go. Welcome everyone back to a new live stream. And I don't know if you've noticed, but we are doing many more live streams than we usually have been because we have much more work to do. And I've seen that I can focus much better when I'm talking to you guys. So that's why when you guys join, four people, let's go. We're totally going to get this. Let's go, guys. Thanks all for being here. But today, we're going to do something different. It's not going to be calculus like we've done before. Calculus is tough, but there are many kinds of toughness. And today, we're going to do something different. It's the other class I have. It's object-oriented programming. It's also it's pretty difficult. However, this is different. It's different. It's a different kind of difficulty compared to calculus. It's right now, I believe I have a lot of reading to do. So I'm just going to be reading to y'all so I can integrate these concepts in my head. And by the way, I've already seen this class last year in GCU and I got a 97. So I think we're totally good. Right now, the thing that matters is speed. Right now, it's not really understanding everything because, again, we already know all these concepts to a great extent. So right now, it's all about speed. It's all about doing all the participation in the challenge activities here for each chapter. And these may seem pretty long, but really, it's all about speed. Well, for me, since I already saw this. For someone who has never seen this class, well, you also have to see the concepts. So we need to read chapter 4 and chapter 5. And I think we're in 4.8. So yeah, so that's what we're going to be doing. And I'm asking myself, what's the use for my iPad then in this live stream? I'm actually not sure. I don't even know what this thing is doing here I'm talking about. Yeah, still need my backpack. I'll be right back. I believe I had, there it is. There it is. Here's my handy dandy, whatever you call that, to wipe my iPad. We also went to swimming today, so I just want to take this out of my backpack. Okay, we're back, everybody. 3 minutes and 54 seconds. Okay. Well, let's do this. Nothing is stopping us. Okay, hold on. Well, first of all, let me see everything that we have to do. Because all of this is due on Sunday. So here's everything that we have to do. So we have a quiz. It's important. I mean, we could basically take it right now, but no, we're not going to do that. Gotcha. Up to 3 times will be different. Highest score will be recorded. 30-minute limit, no extension, obviously. Funny. Okay. Cool. So these are challenge instructions. Here's the video, part 1. Gotcha. And then we have a lab challenge where we actually have to do, okay, individual assignments. Muddy's point's just a survey. And it's this. Gotcha. Okay. Very cool. So, everyone. Whoops. Don't want to. Okay. Let's go now. So I'm going to. Oh, hold on. Wait. Let me just ask Copilot. I am live streaming reading Zybooks for my class on YouTube. Are there going to be any issues? I understand. So I won't be sharing my screen. I will not be sharing my screen because it can violate some copyright rules. But what I will do is talk about it, and you guys will just see me talk about these concepts, and I'll just read these things to you. Okay? Does that sound like a good idea? I think y'all are fine with it, right? Yeah. Okay, well, let's do this. So, Module 1, reading activities. Gotcha. 4.8, problem solving, reusable methods. You have used many methods from the standard Java library. These methods have been provided as a part of the Java platform so that programmers need not recreate them. Of course, the Java library doesn't cover every conceivable need. You will often be able to save yourself time by designing your own methods that can be used for multiple problems. When you write nearly identical code or pseudocode multiple times, either in the same program or in separate programs, consider introducing a method. Gotcha. So when we're doing a bunch of repetition, I think that's when we need methods. Here is a typical example of code replication. Int hours do, so then system.out.print, enter a value between 0 and 23. Hours equals in.nextInt, okay? And we have a while loop when hours is less than 0 and hours is greater than 23. What does that mean? Interesting. Blah, 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 blah. Into minutes do. Oh, I see. So we have a bunch of do while loops. Essentially, we have a bunch of loops that are specific. So maybe we just want to make like a general method, I think. This program segment reads two variables, making sure that each of them is within a certain range. It is easy to extract the common behavior into a method. Pseudocode prompts a user to enter a value to a given maximum until the user provides a valid input. In the scanner to read from, the variable high is the largest allowable input, and we return the value provided by the user between 0 and the high variable, comma inclusive. Okay. And the code is going to be public static int read in up to, that's the method name, scanner in, so we're receiving, comma int high, a variable named high, which is an integer. So int input, that's a variable. Do system.out.print, enter a value between 0 and something plus high plus, okay? Input equals in.nextInt. While input is less than 0 and input is greater than high, return input. I see. I scream. So sorry, I see. So Interesting. Okay, I understand. Then use this method twice. So for hours equals read in up to, we read what the user inputs, comma 23. That's going to be the high variable. So that's the maximum value, like 23 hours in a day. You can't have 24 hours in a day because then that'll be like the 0th hour, I believe. And then in minutes equals read in up to, oh, int up to, and then in 59, whatever. Yeah, but I think I understand overall what they're talking about. We have now removed the replication of the loop. It only occurs once inside of the method. When carrying out the same task multiple times for different cases, use a method. Okay. Note that the method can be reused in other programs that need to read integer values. However, we should consider the possibility that the smallest value need not always be 0. Here is a better alternative. Prompt a user to enter a value within a given range until the user provides a valid input. Read the scanner to read from, that's the in variable. Low, the smallest allowable input. High, the largest allowable input. And return the value provided by the user between low and high, inclusive. The code, public static int, read int between. So in, that's the variable to take the input from the user. And we have our two variables, low and high. All right, that's the method. Inside of the method, int input. Now do print enter a value between low and high. Input equals in dot next int. Read the next integer that the user inputs in the console. While input is less than low and input is greater than high, return input. In our program, we call int hours equals read int between the in variable, comma 0, comma 23. Another program call, int month equals read int between. Yeah, so in general, you will want to provide parameter variables for the values that vary when a method is reused. Here is a program demonstrating the read int between method. Okay, now they're giving us a program. So public class, read time. Read int between. Scanner in, int low, int high, int input, do. Okay, this main. I see. That's fact. I don't even think you need to understand the full example. 4.841, rearrange code into a solution with a reusable helper method. Hold on, reusable helper method. Into a solution. Okay, consider the following. Consider the following simple program segment and note how repetitive it is to prompt for the inputs. Main, scanner in equals new scanner system.in, system.out.print, first time block, double price in the next double, system.out.print, next item, price equals price plus in dot next double, print tax rate in percent, double rate equals in dot next double, double tax equals print times rate over 100, print amount due plus price plus tax. I'm reading like a robot. Rearrange these lines of code into an alternate solution with a reusable helper method. Let's do this. So how is this done? So first of all, what are they even doing here? What kind of code is this? What is it trying to do? Oh, I see. So now we must create a method to do what they did much more efficiently. I see. Okay, let's do it. So public static, read double, open and close square brackets. So what do we need to do? First, we need a reading scanner in. Do we have a scanner in here? Oh, looks like they already did that. Well, they need to read, sorry, they need to call read double. Oh, that's the tax calculator, I see. Hold on, let me understand this quickly. What in the world are we doing here? So okay, I see. Why is main and what a weird code, bro. Main. Oh, I'm stupid. That's the class. Oh, haha. There we go. That seems much better. We need a closing bracket. They don't have a closing bracket. What in the world? I'm confused. Oh, over here. There we go. Wait, what? We can't touch that. There you go. So that's the class. We can't go outside of the class. I don't know why they're letting us do that. Maybe they want to confuse us. That's so weird. We need a, oh, we do have a closing bracket. Let's go. Phew, they scared me. There we go. That looks much better. So what do we need to do? So we need to call read double. um, so first, what do we do? So we have our scanner system.out.print first item. Yeah, I don't know why I said first time, bro. That's weird. Looked like time letters or look really weird. Double price. No, hold on. No, I need to print that. So what do we do? What kind of code is this? It's so weird. System.out.print. So what is read double supposed to do? Just read a double variable? So first, what is read a double? Oh, read a double receives a string. Okay, so this should be right there. Yeah, this method is not going to call itself. We are not in recursion yet. Let's see what else. Read a double. We got to put that there, I believe. And what is read a double supposed to do? Return dot in next double. Oh, cool. Oh, I see. Okay. So we pass first item, the string. Now, what is read double supposed to do? It passed a string. What do we do with that string? Oh, it's called prompt. So where is the word of prompt in here? So do we print out prompt plus that? I don't, okay, where prompt? No, I don't see it there. I don't see it there. Nope, it's not there. Could have been anything of what we use here. No, it's not there either. Let's see. So where could this thing be? Oh, by the way, this should be inside the square bracket, bro. What are we doing? There we go. That looks good. Okay, hold on. So prompt, string prompt. That's a great question. Perfect. Let's see. So first of all, system.out.print first item. Oh, I see. Double price equals in dot next double. So we return the next double here, right? Read double. Why does read double get a string? Price plus next double. So we print that. Read double. The heck? Okay, no. I'll completely fine. So we do this here. All right. Is this good? Oh, okay. I did not understand anything that I did there, but what I did understand was that methods are used to do repetitive tasks. Okay, I'm going to turn on the light because it seems a little bit depressing in here. Well, you know what? It's okay. Actually, it's okay. Yeah, no, it's not that big. And you eat. You know, I went swimming today, and the swimming was really good. Did a bunch of laps, but I did not eat afterwards. So let's do the next participation activity. Consider the following method that computes compound interest for an account with an initial balance of $10,000 and an interest rate of 5%. So first of all, what is no, I don't need to know that. Public static double balance. So this is a balance class. Oh, rearrange the following lines of code to produce a method that is more reusable. Not all lines are useful. Gotcha. Okay. I see. So we have balance that receives the number of years, return 10,000 times. So now we have the power 1.05 to the power of years. Interesting. Oh, smart. Actually, yeah. That's not a bad idea. That's how you compute compound interest. I see. I think I understand now. Okay. And why is this, bro? I need to show more there. Okay, so where is this? I see. So public static double balance. So first, let me read the main. So we create a scanner that double initial balance. So double, that's the variable type. And so this is a variable. Initial balance is a variable equals in dot next double. In dot next double. In dot next double. In dot next. In dot next double. Gotcha. Double rate. So we have a rate. A rate equals the next double. Okay. Will it know when to do that? I wonder. Then we also have a variable years equals next int. Gotcha. Whatever. It's fine. He'll know. Double final balance. So we have a variable final balance equals balance. Here's where we call our method. Balance that receives initial balance, comma rate, comma year. So this can go to the trash because I don't think that's correct. Receives an initial balance, a rate, and a year. I see. Oh, and we get these from the person, from the user. And then we print the final balance times 100, all of that over 100. Gotcha. So it receives 3, it receives 3 variables: initial balance, rate, years. Do any of these work? Initial balance, rate, years. Yep, this one over here. Beautiful. Now, what do we want to do? We want to return 10,000 times math pow 1.05 comma years. So here we have, what is 1.05? That is our rate, right? Yes, that's our rate. So we're not going to use that. We're going to use this. Oh, well, that's good, right? I mean, oh, okay. What happened here? Oh, I see. Our rate, well, a rate of 0.5 per year. So we got to add a 1 to that, though. That should work. Cool. I mean, this is really easy. We are 26 minutes. Very good. Cool. Let's keep going. Which option is the best to make the helper function more reusable? Suppose you were given the task of removing spaces from a string. You need to know where the spaces are. This helper function will tell you removing spaces from a string. And you need to know where the spaces are. Hmm. Very cool. Okay. Now here we are into the challenge activities. Let's go. Consider the following statements which calculate the number of cents and the total and number of cents and the tax, respectively. Which? Oh, sorry. Consider the following statements which calculate the number of cents in the total and the number of cents in the tax, respectively. Let's go. Mm, smart. Okay. So we need to implement these two methods, get sense and get sense. Okay. So I need to introduce a method, get sense, to reduce code duplication. Okay. Get sense. Okay. Whoops, bro. Okay. I see. Okay. So amount in dollars and cents. So I need to return the number of cents and the amounts. So total cents is, no, I'm sorry, I assign the total from this method. Oh, okay. First, what am I supposed to receive? Number of cents in a given amount. Am I going to pass anything? Number of cents. So I'm guessing int number of cents, right? Oh, and gotcha. Okay, so number of cents. Wait, which calculate the number of cents in the total, gets the number of cents in a given amount. So how do I know? So total. So total is going to be my number of cents, right? Yeah, that's their fault if they do that wrong, not mine. Gotcha. Cool. All right, that's comforting. So now, so yeah, int number of cents, and now I got to return the number of cents and the amount. What? Gets the number of cents in a given amount, return the number of cents in the amount. What's the difference? Gets the number of cents in an amount. So if I have, oh, like, but maybe the amount is $5. I see. So I get number of cents in amount, I guess. And how do I calculate how many cents there are? Well, number of cents. So I think I'm gonna get $5. So in fact, int amount. Oh, there we go. And I get $5, and I need to know how many cents are in those $5. So how do I turn the amount into the number of cents? Well, first of all, what is this total going to be? Amounts and amounts in dollars and cents. Gosh, dude, this is so unclear. Hold on. We're not putting. Int x, int dollars, and y. Wow, dude. Okay. So should I just copy this and hold on. Okay, how about that? Failed to compile. And why is that? Helper method error incompatible types. Oh, incompatible types? No, int, everything seems to be good. Oh, wait, what are you passing? Oh, hold on. Next double is a double. I see. It makes a lot of sense now. All right, how about this? I think this should be better. For real? Everything worked well? I'm surprised as you are, guys. I'm just as surprised. Let's go. Okay, let's keep going. Consider this method that prints a page number on the left or right side of the page. If page modulo 2 equals 0, that means if the page is even. System.out.print page. So I print the page. What's okay? I'll have to cool. Else print dot plus page. Okay. Gotcha. Introduce a method is even with the return type boolean to make the condition and the if statement easier to understand. So a method is even. So public static. And am I returning anything with the return type boolean? Okay, boolean. Oh. Boolean is even. So we just copy and paste what you gave me. Okay, so first let me read just the code. Public static void main. Scanner in, new scanner system.in, int page. Oh, gotcha. Page is the page number. Gosh, they could be a little clearer there. It's fine. In dot next int print page number page. Okay. Oh, that goes to print page number if is even page. Gotcha. Oh, so I think all I'll have to do here is simply return true, return false. Okay. Is that all you want me to do? Failed to compile. Oh, and I need to receive something. Page number. There you go. All right, that should work now. Wait, and page number is an int. Oops. Wait, no, hold on. Return type is boolean. No, that's good, I think. Perfect. Next challenge problem. The comment explains what the following loop does. Use a method instead. Okay. So we have a scanner, a line, next line, okay? So it gets the next lines. Print, so count spaces in the line. Gotcha. Okay, cool. Oh, and I have to implement that. Cool. So let's read their pseudocode thing. Counts the number of spaces. Int spaces equals 0. So a for loop. I equals 0, I less than the input dot length, I plus plus. If the input dot char at I, okay, equals a space, spaces plus plus. Simple, right? So you want me to put a method? Count spaces. Count spaces, I see. I need to get the line. Oh. Oh, and I need to return. What do I return here? I return the number of spaces. So int. Num of spaces, I see. Okay. Whoops, actually no. The line. Cool, that should work. Whoops, that's wrong. My bad, I forgot the line is a string. There you go. Oh, what happened? Oh, whoops, this is not input. There we go. What happened here? Missing return statement. Oh. Awesome. And the final challenge activity. Instead of counting the number of spaces in a string, it might be more useful to generalize the method so that it counts any character. Write the method count char or count character. And then boolean. So okay. Whoops. Oh, so this has to be count then. Count. Here we go. Oh, and what's this? Oh, why not? Hello? Why is it not working? What? Oh, hold on. That's 9, not even 8, bro. Oh, whoops. There we go. Sorry, I lost dumb. Awesome. Okay. Well, I'm gonna go to the bathroom and I'll see you all. Cool. Okay, cool. 4.9, computing in society, personal computing. Gotcha, this is the reading. All right, we can do quickly. In 1979, Ted Hoff, an engineer at Intel Corporation, was working on a chip for a manufacturer of electronic calculators. He realized that it would be a better idea to develop a general purpose chip that could be programmed to interfere with the keys and display of a calculator, rather than to do yet another custom design. I see. Thus, the microprocessor was born. At the same time, its primary application was as a controller for calculators, washing machines, and the like. It took years for the computer industry to notice that a genuine central processing unit was now available as a single chip. Hobbyists were the first to catch on. Hobbyists, interesting. Like political guys? Interesting. And what was the other guy's name? Martian Ted Hoff. Oh, Martian Hoff, who is an electrical engineer. Nice. Okay. I see. Hobbyists were the first to catch on in 1974. The first computer kit, the Altair 8800, was available from MITS Electronics for about $350. The kit consisted of the microprocessor, a circuit board, a very small amount of memory, toggle switches, and a row of display lights. All right. Um, Purchasers had to solder and assemble it, then program it in machine language through the toggle switches. It was not a big hit. That sucks. The first big hit was the Apple II. It was a real computer with a keyboard, a monitor, and a floppy disk drive. When it was first released, users had a $3,000 machine that could play Space Invaders, run a primitive bookkeeping program, or let users program it in BASIC. Very cool. We saw this kit, Altair 1800. Interesting. Yeah, it was not a big hit, the Altair 800, because I bet they had to build it and all of that. So no wonder the Apple II did very well, and it was released at almost 10 times the price. The original Apple II did not even support lowercase letters, making it worthless for word processing. The breakthrough came in 1979 when a new spreadsheet program, VisiCalc. In a spreadsheet, you could enter financial data and their relationships into a grid of rows and columns. Okay? Then you modify some of the data and watch in real time how the others change. For example, you can see how changing the mix of widgets in a manufacturing plant might affect estimated costs and profits. Corporate managers snapped up VisiCalc and the computer that was needed to run it. For them, the computer was a spreadsheet machine. And more importantly, it was a personal device. Managers were free to do the calculations that they wanted to do, not just the ones that the high priests and the data center provided. Personal computers have been with us ever since, and countless users have tinkered with their hardware, software, sometimes establishing high successful companies or creating free software for millions of users. This freedom to tinker. Okay, yeah, Okay. Oh, be real time. Cool. Okay. Let's go, Ethan. Gotcha. Do y'all have Be Real? I gotta add you guys. Okay, let's continue. So, looks like that's cool. We're in 4.10 right now. Hold on. What was that snake game we played? That was a fun game. Maybe it's time to take a break, you know? What was it? There we go. Golbrayo, that's the name. Here, I guess I can share my screen over here. Oh, I died. Oh, darn it. Oh, Bro. Bro. What? That's not fair. Yo, what's this? Okay, yo, I think that's it. It's time to focus. 4.10 stepwise refinements. The most powerful strategies. Okay, I'm going to turn on the light, dude. One of the most powerful strategies for problem solving is the process of stepwise refinement. To solve a difficult task, break it down into simpler tasks. Oh, duh. Then keep breaking down the simpler tasks into even simpler ones when you're overwhelmed with each task you have to do until you're left with tasks that you know how to solve. Yeah, definition of stepwise refinement. The process of solving a problem that starts out with a subdivision into steps, then continues by further subdividing those steps. Dude, gosh. I'll rather, like, don't do that because then you get like 1,000 little problems that you can't keep track of. Now apply this process to a problem of every day. You get up in the morning and simply must get coffee. How do you get coffee? You see whether you can get someone else, such as your mother or mate, to bring you some. If that fails, you must make coffee. How do you make coffee? If there is instant coffee available, you can make instant coffee. How do you make instant coffee? Simply boil water and mix the boiling water with the instant coffee. How do you boil water? Microwave, fill cup with water, microwave, heat for 3 minutes. Otherwise, fill kettle. Oh, all right. So gonna talk like if then, whatever. Yep, all of that. Oh, let us apply the process of stepwise refinement to a programming problem. When printing a check, how long are we going? An hour and 6 minutes. We're good. Oh, by the way, sorry, I can't share my screen because that's copyright. My bad. Let us apply the process of stepwise refinement to a programming problem. When printing a check, it is customary to write the check amount both as a number, $274, and as a text string, $274.15. Doing so reduces the recipient's temptation to add a few digits in front of the amount. Interesting. For a human, this isn't particularly difficult, but how can a computer do this? There is no built-in method that turns 274 into 274. We need to program this method. Here is the description of the method we want to write. Turns a number into its English name. So, number, a positive integer less than 1000. Return the number, the name of number. Okay. Public static string, int name. Oh, I'm hungry. Public static string, int name, which receives a number. How can this method do its job? Consider a simple case first. Consider a simple case first. If the number is between 1 and 9, we need to compute 1 to 9. Consider a simple case first. If the number is between 1 and 9, we need to compute 1 to 9. In fact, we need the same computation again for the hundreds. Anytime you need something more than once, it is a good idea to turn that into a method, right? As we saw last or two activities ago. Rather than writing the entire method, write only the comment. Turns a digit into its English name. Digit, an integer between 1 and 9, return the name of digit 1 to 9. Interesting. Gotcha. Okay. So that's like a sub method, I'm guessing. So that's int name. Digit name receives a digit. Numbers between 10 and 19 are special cases. Let's have a separate method, teen name, that converts them into strings, 11, 12, 13, and so on. And integer between 10 and 19, return the number, 10 to 19, right? Public static string, teen name. What is teen name? Teenager name. Oh, I see, like teen. 11, like 13, 14, 15. Next, suppose that the number is between 20 and 99. The name of such a number has two parts, such as 74. We need a way of producing the first part, 20, 30, and so on. Again, we will put that computation into a separate method. Gives the name of the tens part of a number between 20 and 99. Gives the name of the tens part of a number between 20 and 99. An integer between 20 and 99, the name of the tens part of the number. public static string, tens name. Let us write the pseudocode for the int name method. If the number is between 100 and 999, bro, then we show a digit and the word 100, such as 200. We then remove the hundreds, for example, reducing 274 to 74. Next, suppose the remaining part is at least 20 and at most 99. If the number is evenly divisible by 10, we use tenth name, and we are done. Otherwise, we print the tens with tenth name, such as 70, and remove the tens, reducing 74 to 4. In a separate branch, we deal with numbers that are at between 10 and 19. Finally, we print any remaining single digit. Int name, number, part equals number. Name equals nothing yet. If part is greater or equal than 100, name equals name of, oh, I see, huh? Append teen name, name. Notes how we rely on helper methods to do much of the detail work. Using the process of stepwise refinement, we now need to consider these helper methods. Let's start with the digit name method. This method is so simple to implement that pseudocode is not really required. Simply use an if statement with 9 branches. Oh, I see. If digit equals 1, return 1. Oh, so we are going to have to do that. I see. Digit equals 2. The T name and test names method is similar. I understand. I get it. Okay. Okay. Integer name, Java. Class, integer name. Int name. Oh, smart. Cool. Okay. Yo, we're going to have to do all of that. Gotcha. Ah. Ah. Int name. Int name method. Where is that? Cool. Okay. Gotcha. Okay. So what's the difference between it? Oh, gotcha. Well, we do need a name plus name. Right? Seems to check out. Not all tests pass. Oh, interesting. Why is that? Looks like we can only do one of them. Interesting. I wonder why is that? So if part is greater than 0, name equals name plus, Why is this the only else if? Interesting. Hmm. Okay, so it looks like I need to do this. How's that? Oh, all tests passed. Okay, cool. And why is that? Well, let's see. Oh, right, because the 1,000 needs to go first, obviously. Very good. Very cool. Okay. Mm, interesting. That's a good question. 200, I think. Mm, what do you do, like 210? Maybe 13. Let's see, let's see. Anyways, let's see. So, oh, part 0. Digit name. Well, 10. I think it would say 10. Yeah, I wouldn't say 21.3. That's wrong. Okay. Okay. 0. Let's think. So, well, an empty string, right? Yeah. Mm-hmm. Three, 7, and 9. Int name 314. Int part equals number. Through 314. The greater equal of 100. The next line executed after line 12 is going to be 14. Value of name. Digit name. Part over 100. 14. 314. Is it a double? No, it's an int. It's 3 actually. 3. Oh, for real? Well, I don't know what digit name does. I forgot. I'm obviously not going to remember that. Oh, part over 100. Okay, I see. Modulo 100. The value of name. Is 300. So what I'm passing is 3. 3. I'm passing 3, right? So then, oh, wait, part is, okay, what is part, bro? Part is, what is part? Oh, 314. 314 is part. Gotcha. 314 over 100, that's 3. Well, since it's an integer. 3 equals 3 modulo 100. Sorry, 314. 314 modulo 100 is 14, isn't it? 300. Interesting. Okay. Line 15 executes value of part. Oh, so part. So 314 equals 314 modulo 100. Okay. 17 is greater than 20. Oh, it's 20. $14. It goes to 22. 24. A value of name. So what is name? 300. It's 300. Teen name. Part. What is part? Part is 14. $25 and $27 execute. Part equals 0. $37. 31. Lines 4, 7, and 9 execute. What is the value of part as well as number? 4, 7, and 9. $42 and 9. So part equals 42. 10 and 12. So we have a 42. No. Oh, after 12, it's going to be 17. 17. So name. Oh, whoops, name. So it's nothing. Nothing plus space. Tens name. Part. Tens name past 42. I think that's 40 then, right? Yes, I knew it. Let's go. Yes, And 20. Modulo 10. Modulo 10, so 2. 27. Value of name. So name is 40. 40 plus digit part. Let's go. Okay. Prove name method in integer name. Oh yeah, and integer name is class. Is the class. Bro, what's going on? And name is the method. Okay. So 15 to 26. Let's do this. So if what? Um, oh, cool. Okay, so now. Let's see. So now, name equals digit name, part over 100. What's wrong with that? Oh, modify it. Oh, okay. So, oh, it could be this one, actually. Oh, of course, because we already have the name, right? Uh-huh. Oh, I missed the 100. What happened there? Oh, it already has. So, there you go. There we go. Perfect. And the final challenge activity for 4.10. See, so. I don't have to do that. Okay. So, okay. So what part is the header? So they have these headings. Print separator. Print row. What's a row though? A column row. Like, okay, print header. What is the header part though? Where do we? Print body. I see. Oh, hold on. Wait a minute. I think I understand what they want me to do. Print separator. Oh, print element. Yeah, no, we're good. Cool. So all I need is the print row now. So let's do like a for loop. What's that doing? How do I do that part? So we have like a one. Oh, you just want me to do. Oh, okay. It's 1, 2, 3, 4, 5, 1, 8, 27, 6, 4, 5. Okay. So I think I should do. Hmm. Oh, print row. Oh no, I see, I see. So how do you print a row though? So I should do like 1, 2, 3. And what number do I put? Just like 1? Okay. Okay. Okay, that's much better. What? Let's do 0 first. So if the input is 3. Yeah, dude, I don't know what to do. Let's see. So, why is this going on? Oh, I see. Hold on. So, there we go. That's much better. Hmm. Bro. What is 1-8-27? Can you tell me what this is? Oh, items I. There we go. Yeah, well, that should be correct. Bro. Dude, how do I do this? Print F, gotcha. How am I supposed to do that, bro? Push it one more or what? Whoops. Oh, okay. Well, I guess I'll just do this. So. Hmm. Mm. So, stop. Here we go. That should work. Mm. Bro, oh my gosh. Dude, I don't know how to do that. I don't know. What do you want me to do? Oh, wait, hold on. Oh, I see. That should be better. I'm so close, bro. Okay, let's see. I have that right. So now. Okay, completely identical. Now. I'm so close. Cool. Now I just got to do that, but for all of these. Okay. And okay, that should work. All right. Let's see if this works. It worked, yes. Okay, well, everyone, that was a good time, but I'm gonna end the live stream now because we are very tired. We'll see you all next time.